Hello everyone, hope you are doing well. In this problem set, I would like to compare the two seemingly similar differential amplifiers where in one case the load resistance is replaced by a current source where its value is IS divided by 2. So from the DC current point of view, both circuits are similar. Um, okay. And we want to compare two gains, basically V out plus divided by V in and V out minus divided by V in between these two. Mm, I think most of you are familiar with the circuit shown on the left side. Uh, so the main purpose of adding the circuit on the left side was just to give us a contrast between these two circuits. Okay, so I now start to solve this problem, but I recommend you guys first pause this video and think about it for yourself and try to use intuition as much as possible. For example, I would like you guys to see uh, uh, how do they compare. For example, V out plus divided by V in. Is it larger on the right side or in the left side, in the right circuit or in the left circuit? And similarly, V at minus divided by V in. I think is a good start to cultivate our intuition from that respect. Okay, so let's move on. Um, I think circuit A is easy peasy for you guys. And as I said again, this is just for a contrast for part B. So we go through it very fast, just for people which may not be familiar with it. But still we use concepts which are used a lot in circuit design, especially integrated circuit. So we know that for fully differential circuits, we can use the concept of virtual ground, basically. So here we can use the same thing for circuit A, and as a result, the circuit can be decomposed into two independent circuits. Okay, so it's rather easy to show that uh, V out plus divided by V in equal to minus V out minus divided by V in equal to minus half GM RL in parallel with R out, right? Now let's move on to the circuit B. We do a simple modification to the circuit. The current mirror can be, the current source can be modified or decomposed into two current sources, where each one is half of its value, namely ISS divided by 2. Okay, now let's use a cut set. So if you smartly just draw a cut set here, cut set is just a glorified version of a KCL, where instead of looking at the summation of all currents at one node, we look at the summation of currents for a semblance of ensemble of two nodes or more, basically. Uh, so here, because we have ISS2 coming in, ISS2 going out, the current going outside of this cut set, let's call it I1, is 0. And I1 is equal to 0 is basically is for DC current as well as AC. And this means delta I1 is also 0 as well. As we will see shortly, that would be very helpful information. So because of this, basically these two circuits are basically they don't have interaction. There is no charge interaction between these two circuit. Okay, and then let's do the concept 2. So the concept 2 can be drawn as shown here. If we do the same thing again, we see that the current through RL is ISS divided by 2, and even if we fluctuate V in divided by 2 or minus V in divided by 2, because the cut set should be always hold, the delta I2 also would be 0, which is basically the small signal current drawn into the RL. So from this observation, without writing any equation, we can see that V out plus divided by V in must be 0. Another way of looking at this would be that for every amplifier, the decimal signal gain can be calculated as a multiplication of the GM and R out. These are effective values. So for this one, you basically look at the output impedance, and GM is the effective transconductance of the amplifier when its output is shorted. Okay, so because the transistor is degenerated by an infinite impedance associated with the ISS divided by 2, GM is basically 0. And R out is basically RL, because the impedance looking into the drain of the amplifier is infinite as a result of being degenerated by an infinite impedance. So again, we can see that it's 0. But I think the way that I discussed it in at first is more, I think, is more beautiful, and it's a new kind of understanding. Not new, I would say, it's a better looking into the machinery of the circuit. Okay, so before going to the right section of this circuit, let's calculate Vs. Okay, let's redraw the circuit again. We know that this node is ground, or we found it is basically 0. Therefore, in a small signal, it can be connected to ground. There shouldn't be any difference. That's substitution theorem. So if we do that, for the small signal model of the amplifier, for the transistor, we have a RO connected between drain and source amplifier. By connecting that node to ground, we basically add this R out to the output of the circuit, and as a result, the circuit can be simplified to this. And this is a common drain amplifier, so Vs would be or in a more familiar form, it will be where alpha is GMR out. Okay, this information will be used for calculation of the gain of the right portion of the circuit. So I haven't drawn the ISS2 at the drain and also at the source of this amplifier because they don't matter in a small signal analysis. Okay, why it doesn't do the V out minus. Okay. Here we can use superposition, or we can just write one equation to calculate V out minus. I do the superposition, and you guys can do the other way, where you just solve this question in one strike. So if you want to use superposition, either I need to make the Vs equal to 0 or Vin equal to 0. Okay, the gain of this guy is obviously easy. And for this guy, we know that because all the current of the transistor, the small signal, namely GM VGS, needs to circle inside the internal R out, therefore you have alpha Vs across drain and source of the amplifier. So as a result, V out minus is Vs multiplied by 1 plus alpha, where can be written using this information as so we need to add these two together. So V out minus divided by V in is alpha divided by, sorry, what I'm talking about, basic alpha. So basically, if we look at the total gain of these two amplifiers, V out divided by V in for this guy is GM RL, and for this guy, as you might guess, or obvious by now, is GM R out. So basically RL doesn't matter. Because as we showed, you can even assume this is direct connectivity, and this doesn't matter. And the circuit is actually equivalent to this. So basically what I've showed is these two are essentially the same in terms of total gain. Okay, so hopefully you enjoyed this discussion. Um and eventually within a day or two I will post some questions related to this discussion, so I make sure that you have learned your lesson, and I try to also solve those equations, those circuits as well. Thank you and have a great day or night. Goodbye.